Hi everyone, this is A. Voglish, Assistant Professor, Department of Computer Engineering, Andhra Group of Institutions, Adani, Hyderabad. These are the basic slides for understanding process scheduling. Here, before going to discuss about a scheduling scenario, I want to introduce you two basic modules in operating system. One is a scheduler, another one is a dispatcher. Scheduler. The task of scheduler is select one process among many processes which are in ready queue. Here, the processor should be in ready state. Then only the scheduler can select one process to execute. So here, the main task of scheduler is to select one process among many processes which are in waiting state. Another important module is dispatcher. Whatever the process that is selected by the scheduler, that process is assigned to CPU for execution. That is the main task of dispatcher. Here, that's why here, give the control of the CPU to process which is selected by the scheduler. This is the main task of dispatcher. Another important task of dispatcher is context switching. Means that switching from one process execution to another process execution. For switching, whatever the thing that is required, that is arranged by dispatcher. Another one is jump from one process to another process. From jumping from one process to another process, whatever the return address that you need to handle, that is handled by dispatcher. And another important factor for the dispatcher is that is a dispatcher latency. Dispatcher latency means the time interval between to stop one process and start another process. The time interval between to stop one process and to start another process, that's time what we are calling as dispatcher latency. Here I mention you some of the algorithms. First one is the first come first serve. Second one is the shortest job first, shortest job next, what we today, and priority scheduling, and fourth one is the round robin scheduling. First one is first come first serve. As in the case of first come first serve scheduling criteria, the process which came first into ready queue, that process can execute first. That is the main theme of first come first serve. That is, jobs are executed on first come first serve basis. It is a very easy to understand and it is very easy to implement. And the third important feature of this one is it is a non-preemptive scheduling algorithm. It's here, non-preemptive means once the process is assigned to the CPU, until that process executes, the CPU does not leave that process. Otherwise, second case is if the process is required any input value, in that case the CPU can release the process and then again it can take over for execution. So simply here, non-preemptive scheduling point of view, there are the two cases. One is once the process is assigned to the CPU, in two cases only it will be released. One is the process should be complete, other case is the process needs some input output value. Here the small examples what I given for understanding. Here three processes. Process P1 burst time is 23, means for giving results P1 should execute 23 milliseconds. P2 needs 3 milliseconds. P3 needs 4 milliseconds. This is a Gantt chart. First of all, P1 came first, that's why CPU start execution of P1 and P1 should be executed up to 23 milliseconds. From there onwards, P2 will be start. That will be execute 3 milliseconds. That's the 23 plus 3, 26. From hereafter, P3 will be start execution. The P3 burst time is a 4, that's 26 plus 4, 30. This is a Gantt chart which can be exhibits the process execution on timeline. So every time we should calculate the average waiting time. So here P1 is not waited any time, that is a 0. P2 is waited until the P1 completes, that's why P2 waiting time is a 23. And P3 is waited until the completion of P1 and P2, that's why P3 waiting time is 26. So totally the average waiting time is 0 plus 23 plus 26 by 3, that is 16. The main disadvantage of first come first serve is if any process came first with highest burst time, remaining processes should be wait until the completion of that first process. And another drawback is average waiting time is very long. Second scheduling algorithm is the shortest job first. As the name indicates, that shortest job first, that is the job or the process which has lowest burst time, that will be executed first. The process which is having shortest time, that will be executed first. This is a non-preemptive scheduling algorithm. Best approach to minimize the waiting time. This is the shortest job, so it is the best scenario for minimizing waiting time. Here I given some small problem. Here P1 burst time is 23, P2 burst time is 3, and P3 burst time is 4. Here smallest burst time is 3. That's why CPU start the execution of P2. That's what I mentioned in Gantt chart. P2 will be executed up to 3 milliseconds. After that, next minimum is 4, that is the P3. The P3 is start execution, that is from 3 to 4 milliseconds. After completion of P2 and P3, next available process is P1. So the P1 is burst time is 23. Here P1 will be executed from 7th milliseconds to 30th milliseconds. This is a scenario how the processes will be executed in by using shortest job first. These are the waiting times. P1 is 7 milliseconds waited, P2 is not waited, P3 is waited 3. So average waiting time is 3.33. Here the drawback in shortest job first is we cannot predict next process burst time. The third scheduling algorithm is the priority scheduling. Here each and every process should be executed based on their priority. So here the point is highest priority process will be executed first. This is a non-preemptive and preemptive scheduling algorithm. Is that this priority scheduling algorithm will be execute the preemptive and non-preemptive. The best approach is to minimize waiting time. Here some examples I given you. P1 burst time is 23 and priority is 3. P2 burst time is 3 and priority is 2. And P3 burst time is 4 and priority is 1. Here highest priority is 1. That's why CPU start the execution of P3. Next priority is what P2. That's why P2 will be started. Next priority is what 3. That is the P1. P1 will be started. These are the waiting times, and this is the average waiting time. The fourth one, very important, round-robin scheduling. Most of the modern operating systems will use the round-robin scheduling algorithm only. Here, there should be a time slice. Means each and every process should be executed up to a particular time slice only. After that time slice, forcibly the process will be removed from the CPU. Then another process will be start execution. That is, it is a preemptive scheduling. After time slice, the process is forcibly removed from the process and assigned to new process. This is a scenario. If the time slice is 3, then each process is executed up to 3 units of time. Then it is added to tail of the queue. This is a scenario what I mentioned. P1 is 9, P2 is 3, P3 is 6. Now here each and every process will be executed up to 3 units of time. These are the waiting times. Thank you.